Okay, so the question has been here in front of you for a while. Can you guess why I'm showing you this picture? Or maybe the question should be, what is it? This thing. What's it, Jace? Testing if you're colorblind. Oh, but so it's a. How would it be a colorblind test? That's a good question. It's not really a colorblind test, but I guess it could be, sort of. Like if you look at this and say, this looks normal to me, then maybe you're colorblind. But this thing, what is this thing? Quinn. It's supposed to be a stoplight, but there's something very wrong with this stoplight. Harriet? Yeah, so this should be orange or yellow. I mean, kind of an amber, yellowish color. And where's red on the stoplight? Harriet? It should be at the top, and green should be at the bottom. And have you ever seen a stoplight around Essex where you got the colors in the middle and then the outside is white? You ever seen that? There are some white ones? Where are they?
Oh, no. I've seen them out of state.
Out of state. Most of the ones I've seen have been, they've got the colors and then it's surrounded by black. And then there's yellow usually, painted on them somewhere. But generally there's red and yellow and green and then sort of a black light. And they've got these things that stick out over them, little roofs that come out. Do you know why those are there? Could be, and also to keep the sun from shining down in them, so you can see light when it's coming out of the darkness better than if there's a bright light on there. So both of those. All right, so I'm showing you this screwed up traffic light, and it's got a dot in the middle. I still don't think I've given you enough information to guess what's going on here. So let me just jump to it. I'm going to switch to a PowerPoint because this PowerPoint has much bigger pictures. It'll fill up the whole screen. All right. This is kind of weird. On my computer screen, I've never done this before. Show slideshow. It looks different than it does up here. So this is kind of bad for the people who are watching this on YouTube. Let me see if I can switch this. Black or unblack? See all slides? Display settings. So it's just really strange. Oh, this will be fun. I'm going to swap presenter view and slideshow. So, see what I'm seeing? It's kind of ridiculous. Oh no. Uh-oh. I don't know how to undo that. Because I can't click up there. I've got to escape. Alright, maybe I'll just go with it like this. So the point of this slideshow usually is to introduce, this is the way I start out with stars. And we look at this picture and you notice that a few things about stars. There are stars of different sizes. There are a whole lot of stars. And what's something else that's varied here if you look at these different stars? Megan. Yeah, so there's brightness, and in addition to brightness, what else? Quinn? The color, yeah. So here's a red one. Here's one that's kind of bluish. The blue doesn't show up very well on here. I can see it better on my screen. Here's another one that's sort of bluish, orange, yellow. You can see a lot of different ones. So to understand stars, we have to talk about light, which is why we're doing this stuff with light. Now, here's the point we're about to get to, and I'm going to put my picture up here so people watching this will know what I'm talking about. So look at this dot and don't move your head. You may have done something like this before. It's gonna create an after image. So keep your eye on that dot and keep your head still. Don't turn from side to side, just keep straight. You can blink. Blinking is fine. And after you've been staring at this for a while, maybe 20 or 30 seconds, until it starts to get uncomfortable and you won't really want to stop, Then I'm going to switch to a screen that has nothing but white on it. This is the next screen down below. And there's going to be a black dot in the same place. And all you do is keep looking at the dot. And you can blink when you get to that, but you should see something else other than the black dot. Ready? Here we go. All right. So blink and keep looking at the dot. Do you see something? You should see a regular traffic light. So instead of seeing the one with green on the top and red on the bottom and purple in the middle, you should see something that's sort of like red on the top, green on the bottom, and then sort of yellowish in the middle. It's not perfect. Megan, did you have something to... You saw what? Yeah, the problem is I created this little illusion here myself, and I didn't use the perfect colors for it. But let's try it again. Just keep staring at it. Another thing you may not have noticed the first time is that when we switch to the white screen, what you're going to see is instead of sort of correct colors on a white traffic light, you're going to see, or sorry, instead of the sort of wrong colors on a white traffic light, you're going to see the right colors on a black traffic light. And instead of this being white on a black background, it's going to be black on a white background. So, but the important thing is to hold really still, and I'll talk about why that's important in a minute. And then I'll get to the point of what's happening. Okay, ready, set, keep looking. And one thing you may notice, this, I can actually see an after image just because the projector must have such a thing. But if you blink and you move your face around, you'll actually see the traffic light moving all over the place. You see what I'm talking about? So let me, now let me explain what's going on, and then I'll show you another one. You can see off on the side here, there's an American flag one and some other kind of cool effects. I'm going to, however, switch to, oh no. So for the people at home, you're supposed to be able to see through my webcam. Hopefully you'll be able to in a second. I just need to unplug, I guess. There we go. All right. I don't know if you know how your eye works, but I'm going to show you some interesting things about the eye today. This is earth science, but I think that this is kind of interesting, and interesting stuff is sometimes worth learning even if it's not related to exactly what you're doing. So let's say you're looking at a person. This is the person you're looking at. Have you ever heard that inside your eye everything's flipped upside down? It is. So if this is my eye or your eye or anybody's eye, there's the pupil, I don't know if I'll draw this right, but there's a lens. I'm just going to draw the lens of your eye. The lens is like a lens of glasses or a magnifying glass or whatever, and it bends light. We might talk about the bending of light later on. Maybe draw your nose just so you can see where all this is. So you've got an odd nose, odd lips, doesn't matter. There's your hair. So what happens is the sunlight up here, or the light from the room, shines out in all directions. And some of that hits this person, and then some of it gets absorbed and some of it gets reflected, but a little bit of it gets reflected and goes into your eye like this and hits here. Same thing happens on your foot. Some light shines on it, it gets reflected out in all directions, and some of that light from your foot goes into your eye, goes right through your pupil here and hits the back of your eye. So your foot, if I'm looking at this person, that person's foot is shining right up here on the top of my eye, on the back of it. And the person's head is right here. So that's the image that I see when I'm looking. And on the back here, there are different parts of the eye. There's one part called the fovea, which is really sensitive to it. it allows us to see really nice, clear, crisp images right in the center of wherever we're looking. And it also has color receptors in it. So I'm simplifying here, but there are these little cells on the back of your eye. Let's just say they each see a color. That's simplified. So there are some that see red, there's some that see orange, some that see yellow, green, blue, indigo, violet, and they're all right back here. So let's say we're looking at a blue person. This person's totally blue. Nothing else. There's no red light coming from that person, no orange, no yellow, nothing else. All this blue light is going back here, hitting the back of the eyeball. Which kind of receptor is getting a workout? Which ones are like doing their job? The red, orange, yellow, green, blue, indigo, or violet? If you're looking at somebody who's blue, which of these receptors is going to be doing its thing? The blue one. So the blue one is getting a workout. It's getting really, really, really tired. The rest of them are getting a rest. So if you suddenly take away this blue person and you just put a white sheet here, totally white, then all these receptors are going to be getting a workout because white's made up of all these colors. But which one's going to be kind of tired out and is not going to work very well? The blue. So what you're going to see is red, orange, yellow, green, indigo, and violet mixed together. And it's not going to look quite like white. It's going to look like white where you've taken the blue out. So let me go back to this. We'll do the American flag now. The American flag one's better because somebody who probably was a professional artist or somebody who works with colors did this one. Okay, so now here's the American flag. Take a look at that spot in the middle. I'm going to turn these lights off because I think it works better. So don't move your eyes. This is going to be hard because I'm going to talk for a little while. If you're looking right there, then toward the bottom of your eye, this turquoise is coming in and hitting the bottom of your eye somewhere, and because it's going through. And then this turquoise is hitting the top of your eye somewhere because it's flipping upside down in your head. And wherever this is hitting, the cells of your eye that see turquoise, they're getting really tired. They're getting fatigued. And when we switch to a white background, what you're going to see is the white, what it looks like if you take the turquoise out and leave the rest of the colors. One thing about these black lines, there's no light coming out of those. So wherever the black is falling on the back of your eye, every single receptor back there is getting a good rest. So this is like you sitting in the dark and just looking, and your eyes are adjusting to the dark. When we switch to the white sheet, the part of your eye that's been getting this rest is going to see not just regular white, but it's going to look super white because they're getting such a rest. All right, here we go. Switching to white. You see the flag? Now, the whole point of this is to show you that this really is white right here. But you're seeing these other colors, and they're always there. White is made up of all the different colors of the rainbow. It's made up of red, orange, yellow, green, blue, indigo, and violet. All those things, but you normally can't see them because when you mix them together, you get white. And one way to see the colors is to take a little piece of glass. Does anybody know a little triangular piece of glass and have light shine through it and it splits it? Does anybody know what that's called? Begins with a P? Prism. So if you shine light through a prism, you can get it to separate into its colors, but this is another way to do it. At this point, it probably looks just plain old white to you again because all your different color receptors are just sort of equally rested. Let's see what else I've got down here. Oh, I don't have that one. Must have taken it out. There's a really interesting one. I can probably just Google this up, but this one's just black and white, but it's really cool. It's I don't want you to think this is any kind of a religious thing, but let me do Jesus after image. Black and white, Jesus after image. bet I'll be able to find it. Okay, yeah, here it is. The problem is going to be finding a white thing that I can switch to after we look at this. Let me see if I can open this up in a... Oh, you know what? I can insert this into my slideshow. Oh, come on. It didn't seem to be working. Sorry, I should have set this up this morning. I thought it was part of my slideshow. Okay, so I'm just going to copy it with the snipping tool. And put it in the PowerPoint. New slide. That. Okay, there we go. And then let me put a new one of this after it. I'm going to duplicate this slide, and then I'll put this there. All right, here we go. Oh, except this one you may have already seen. I'm going to get rid of this. We don't really need that. So just pick a pick one of these little spots here and look at it. So this doesn't pick out certain colors and remove them from white. This is either going to pick out all the colors of white light. The part of your eye that's seeing this, the red receptors, the orange, the yellow, the green, they're all getting tired. And then the part of your eye that's being hit by the black, sorry, I didn't mean to do that. I'll just leave myself out of this. The part of your eye that's being hit by the black is all getting a rest. So when we switch to the next screen, you're going to see all the black is going to be intensely white because those cells were rested, and all the white is going to be black. And somehow it just looks very different in the after image. So keep looking at this for a moment. And one of the cool things, it looks like Jesus is floating around in the picture. And one thing that's odd is with the American flag, I can kind of tell it's an American flag before. In the green weird picture, this one. But this, I wouldn't have known what it would look like. Here we go, switching to white. Do you see it? Yes? No? Oh yeah, all right. So that's enough. There are probably a lot of other things you can find after image kinds of pictures. And if you ever want to make one, like let's say you wanted to color an American flag so that if you stared at it and then you stared at a white sheet of paper, you would see a real one. Guess how you decide which colors to use? You're all so quiet. So what you would do is get a real one and stare at it, and then stare at some white paper, and when you do, you'll see the opposite colors. So you can look at this, and then we'll look at white, and that'll tell us what colors we would need to use if we wanted to make something we could look at and then see this. So when I switch to white, if you've been staring at this, you should see a flag that kind of looks like the one I showed you earlier. So that can go either way. You still see Jesus? That's funny. All right. So I'm going to go to the notes now. So hopefully you've got your dig around in your backpack. See if you can find your notes from yesterday. And we're going to continue. Oh, you know, maybe we're not. But get those out. We're definitely going to do something with those. This is what I'm talking about. I apologize to all the people who are getting busy watching this video. So we did the front of this yesterday. We're going to do the back of it today. And actually, I need to get back to quizzes. That's a really important thing. So people at home, make sure you're hanging out for that. I want to go over those quizzes, and I want to give you a chance to do a retake. And we'll talk about how you can do better on it. Oh my! Okay, thanks. Okay, so just to quickly sum up what we did yesterday, this was, this is called the electromagnetic spectrum. These are the different kinds of electromagnetic waves that there are. They're all around us right now. Not a lot of ultraviolet and X-ray and gamma rays going through us. That would be bad. But there's lots of visible light in this room. That's why we can see. Infrared, you would know it if it disappeared. You would start to feel cold. If suddenly you were just put into outer space where there's no or very little infrared coming in at your body, you'd be able to tell a difference. In here, we don't really notice it because we're in it all the time. Microwaves, I don't think you can feel that. Radio waves, you can't, but they're here because the radio would work. We talked about wavelength. So wavelength is from one spot in the wave to the next similar spot. So I could go one wavelength. I could start right here. Tell me when I get one wavelength forward. Just tell me when to stop. Please blurt out and tell me when to stop. Almost. Yeah, I would say right there. So you can either go from crest to crest or trough to trough, or you can go halfway here to halfway there, or you could start here and go to there. So wavelength doesn't have to be crest to crest. These are all the colors of light in order from longest wavelength to shortest. The shortest ones, they have the most energy. If you tried to shake a rope and you wanted it to look like this, you'd have to shake really fast, like you saw me doing yesterday. In order to make the rope look like that, it wouldn't take much energy. So these have more energy, these have less, and that's why the hottest stars are blue, because the hottest stars give off kind of blue and indigo and violet, everything on this end, and you mix it together and they look blue. And the coolest stars, they give off these colors, red and orange and yellow, and if you mix those together, they look red. Now here's the funny thing. If you have a star that's not cool and it's not hot, but it's sort of in the middle and it gives off all the colors like this, and you mix all those together, are they going to look greenish? If we mix all the colors of light together, what color do we get? What? White. So that's why you don't see a green star on here. There are red stars at this end of the sort of the heat spectrum and blue stars at that end. And as you move across, they go red, orange, yellow, and then whitish in here. And then these all, we just lump them all together and call them blue. I don't really know why. Seems like there are a lot on the cool end, red, orange, and yellow. And then the blue, those are the hot ones. And then white seems like it should be right in the middle. I don't really know why it's like that. But I do know why there are no green stars. Okay, what do you see if you mix mix of paints? Okay, we need to fix this. What do you see if you mix paints of all different colors together, and why does this happen? And then number 7, what do you see if you mix light of all different colors together? Why does this happen? So let me go to a couple of links that I found a little while ago. There we go. One is called the RGB color model, and I keep getting this mixed up with Ruth Bader Ginsburg, but that's RBG, not RGB. So I guess I can't really put my picture here and keep clicking this. I clicked the wrong thing. So over here on the right, this is good. This is showing you green light. So somebody just had three projectors, and they had a green filter over one. So the projector projected this green light. And then they had another one, and it's projecting a blue spot. And they have a third one that's projecting a red spot. And then where they overlap, if you have 2 different spots of light overlapping, would you expect that to get brighter or dimmer? What do you think? More light, is it going to make it dimmer? It'll make it brighter. So red and green mixed together, when you're talking about light, makes yellow. If you mix red and green paints, do you get yellow? That's a different kind of thing. So you can see here, if you mix red and blue light, you get cyan, I think. maybe I'm getting, no, this is cyan. This is magenta, and this is yellow. And then if you can see where they all overlap together, you get white. There's a cool video that I found down here. I don't know if I'll be able to play it, but just it's so cool that I'm going to try. Sorry, my mouse isn't working very well. It's somebody made it to show how you can mix together colors. Maybe because it's not a YouTube video, this will work. So somebody just has a computer screen with 3 flowers of different colors. Got red, green, and blue. And these are the reflections off little pieces of, I don't think it's glass, I think it's probably acrylic. And with these reflections, you'll be able to see the reflection on the glass, but you can also see through it at the same time. So somebody's just going to show how you can put these 3 flowers colors together and you can get the one up on the top. Keep watching. It's just a laptop with reflections on these pieces of acrylic. So pretty soon, I'm going to take a risk and pause it here. So what we can see right now is the reflection of this on there, and the green one's reflecting here, and the blue one's reflecting there. And the cool thing is we'll be able to look through all 3 of these pieces of glass in a second. And this purple and that green and that blue, they're going to be mixed. And what are we going to get?
Thank you.
What?
Absolutely.
White. It's going to look just like the flower at the top. So there you go. So with light, the more you add together, the brighter it gets, and the brightest thing is really white. That's the brightest color of all. It's not really a color, it's the combination of colors. So now let me show you CMYK. This is like what happens when you add paints. I'm going to click on this. So in your printer, if anybody has a printer at home, have you ever had to replace an ink cartridge and it'll say, replace the cyan, it seems like it's always cyan. And at least ours, we might have plenty of all these other things, and I just want to use black, but it won't let me because there's not enough cyan. There. So this is called a subtractive process. So as you mix cyan and yellow, you get green. This is like mixing paints. Yellow and blue make green. And in this case, magenta and yellow would make red. I don't know if you've ever done that with paints. If you mix magenta and cyan, you get purple like this. But as you mix these, it gets darker. And as you mix them all, it's black. So what's happening here is that when light hits this and then reflects off, cyan is absorbing everything except cyan. And magenta absorbs everything except magenta. And yellow absorbs everything except yellow. So when you mix them all together, they absorb everything. So the way paints work is they take certain colors out of light and reflect a few, and that's the color you see. So when you mix paints, the more paints you mix, the more they're going to absorb, and the less they're going to give off. All right, so that takes us to here. And I wrote these out last night and I had some good answers. Hopefully whatever I write here will be as good as what I wrote last night. I was very happy with it. When you mix paints of all different colors, what do you see? What color do you really see? You just mix them all up. What? Kind of brown. It should theoretically be black, but it's sort of brown. So I'm going to say a dark brown color. So just so you know, this is not the most important thing we're doing, but I think this is sort of, it gives you a deeper understanding of light. So you see a dark brown color, and why does this happen? So I'm going to say each paint absorbs some colors of light. and reflects others, or reflects the ones we see. Absorbs some colors of light and reflects the ones we see. I'm not sure that I'm happy with that. I'm going to leave it with that though. If we add all paints together, they absorb everything. I'll say all colors and reflect nothing. This isn't a super important thing. I'm not going to really ask you this on a test, but I feel like it helps you understand what's going on with light. So paints and light are different. Paints absorb light, so the more paints you mix together, the more light you absorb and the darker things get. Now if you have light, if you mix all the colors of light together, you see white. And I'll just say each color of light that you add makes the image brighter. Until all colors produce white. So you could do this if you took red, orange, yellow, green, blue, indigo, and violet, all those together, and you start adding red and then orange, then yellow, then green, then blue, indigo, and violet. It would get brighter and brighter and brighter and brighter and brighter until the end you'd have white. If you mixed red paint and orange paint and yellow and green and blue and indigo and violet, then it would get darker and darker and darker, because this one only reflects red and absorbs other stuff. This one only reflects orange and absorbs other stuff. And the more you add, the more it absorbs. Sort of. It's not perfect. White isn't exactly a color. What is it? What is white? It's not a color. Red, orange, yellow, green, blue, indigo, and violet, those are colors. White is all colors put together. So if white is all the colors, what is black? No color. And I'm going to go back to my what is white? I'm going to say all colors of light added together. And when I say light, I mean visible light, the kind we can see. And now, sort of putting things together, go back to stars. The hottest stars are blank and the coolest stars are blank, but medium stars aren't green. Why not? So this is color. What's the hottest color of a star? Blue. And the coolest stars are? Red. Good. So going back to my list here of all the wavelengths, the hottest stars are over here, which makes them red. The coolest stars are over here, or wait, I said that wrong. Hottest stars are over here, which makes them blue. They have the most energy. The coolest stars are over here, which makes them red. Medium stars would be right in the middle. You remember why they're not green? So you can't, stars don't just give off one particular color of light. So it's not like red stars just give off red. They give off some red and some orange and some yellow and probably some infrared over here that we can't see. And you mix all that together and it looks reddish. And these stars don't just give off violet or blue or indigo. They give off all of these. And green, oh sorry, stars in the middle, they don't just give off green, they give off all of these. So if you take green and you take the red end of the spectrum and the blue end of the spectrum and you mix it all together, what color do you get? the stars in the middle give off every color, and every color is white. So medium temperature stars aren't green. Medium temperature, I'm going to just abbreviate. Medium temp stars give off every color, so they look white. And I could do a really detailed explanation there, but I don't think it's super necessary. Which stars are hottest? Larger stars or smaller stars? I think I've addressed this before, but maybe not. I'll draw a star, and I'll give you one big hint. This star, the big one, has a lot stronger gravity compressing it together. The little star, its gravity is much weaker. So this one is being compressed more. So which ones are hotter? The big ones or the little ones? Which one? The big ones. So the more compression, the more squeezing, the more things get heated up, because as they compress, their molecules get pushed and they move around a lot faster. So larger stars are the hottest. Smaller stars are coolest. Why? Because large stars are squeezed more by their stronger gravity. And finally, if larger stars are squeezed more by their gravity, and that makes them hotter, and smaller stars are cooler, what color are the largest stars? So would they be a hot color or a cool color? Hot. Which is the hottest color? Blue. I missed this a minute ago. Remember when I was pointing at this and I was talking about hot things over here that are red? The blue end, those are the hottest. So the largest stars are blue. And what color are the smallest stars? Red. Okay. Now, I'm going to put a little box around all the things on here that I think are most important. Some of these are good that we went over, but they're not super important. So starting from the very beginning, this word, this name, the electromagnetic spectrum, I'm not sure at this point that that's a super important word. I want you to have seen it and heard it, but I don't know that I'm going to ask you that on this next quiz. So, stars give off, which ones can our eyes see? Of course they can see. Number 3, this is super important. I want you to know what a wavelength is, what a trough is, what a crest is. That's important. Number 4, this is super important. You need to be able to tell me, if I ask, what are all the colors of visible light in order from longest wavelength to shortest wavelength, you should be able to do this. And then if I ask you, rank these according to how much energy they have, you should be able to do that too. Number 5, this is definitely important. You need to be able to put stars in order of how hot they are based on their color. But if you can remember this, it all starts with Roy G. Biv. And if you can remember that red is the longest and violet's the shortest, then a lot of these things just fall together. It's not really like you're memorizing. Once you have this, figuring these out is not so hard. 6 and 7, I don't think they're super important. Number 8, number 9, yes. White is all the colors of light mixed together, and black is no color, it's the absence of light. That's important. 10 and 11, definitely. So, there's a practice that I made where you'll be doing some of this stuff, and let me show you what that looks like in Google Classroom. I don't know if I put a link here, but it's here. right here, waves practice. So it's a quiz. Somebody's already turned it in. Let's look at the first one. Use this diagram for the following 3 questions. Which letter is a wavelength? Which letter shows a crest? Which letter shows a trough? This one, this one we haven't really talked about today, but I think you can figure it out. Here, these are going to be a lot of clicking for you. Rank the colors of the rainbow according to the amount of energy in their waves. And rank these star colors according to their temperature. And one thing you'll notice is I made 3 points for some of these questions. The point values aren't important at all. You just do this and I'll give you credit for it. But that's because when you get down to this, I could either make it 7 points or no points. And I didn't want this one to count so much more than everything else. All right. I'm going to stop this stream and pass out quizzes. People at home shouldn't go away because I'm going to go over the quiz. And come up with some suggestions. You know what? This would be a good little, let's take a 5-minute break. If anybody in here needs to go to the bathroom, let's go to the bathroom. If you need to go up and go out and walk around in the back of the room, spread out, make sure you're 6 feet away from people, do that because I'm going to have to talk to you some more. And I'll pass out the quizzes while you're doing that. Yeah. So there are 2 grades on here. One is at the top, that's your overall grade. And then you can see the grades for the individual pages at the bottom. Most people did really well in the front, but not the back. You got a smiley face, that means you were above 90%. There weren't very many. There were on the first page, but not on the second page. And when we retake this, if you just want to retake half of it, if you just want to do the back or the front, that's okay with me. For anybody who didn't get theirs, you all got it, right? Somebody calling me? Yeah. Yeah? You don't want me to put it in yet? Yeah, I won't put it in yet. I haven't put them in Power School yet because I wanted to give people a chance to redo it. The question is, though, when are we going to do it? And I won't see you all again until next Thursday, so I'd have to wait until next Thursday or have you do it from home. And the home thing is just it's a hassle. When people take quizzes at home, they send me pictures of them, and they're all sideways and dim, and I can't read them, so I'm tempted to just wait until next Thursday, but I won't put it in until then. The problem with that is we're probably going to have another quiz by next Thursday, so we'll have all these quizzes piling up. Maybe we should just take next Thursday and Friday and make sure that everybody is just totally caught up. And remind me, send me an email if you're feeling like, hey, I've got this new quiz coming and I have these 2 old quizzes that I want to redo, and can you just stop for a second and let everybody catch up? Email me and say that, and I'll listen to you. People at home, are you still there? I see you.
Yeah.
All right. So I'm about to get going with the quiz again, and some of you haven't taken this quiz. So, I guess you can just take the retake without having taken this one. It's in Classroom right now, and I should probably get that out of there. So I'm going to unassign it for the people who were at home that I assigned it to. Let's see, it's right here. Graded one of these. I guess I should stop sharing my screen for a second and mute this so nobody can see what I'm doing, because it might have a student grade on here. All right. So those of you who are at home, you can't take that one now. You'll just have to wait for the next one. But you could have taken that last class. Let's see. Now I've got to start sharing my screen again. There you all are. And I'm going to record this. Call this the, oh my,